In the interconnected world of computer networks, efficient communication reigns supreme. Every second, countless data packets traverse the globe, connecting people, businesses, and systems in a seamless web of information exchange. Devices rely on a sophisticated system of addresses and protocols to navigate the digital landscape and exchange information seamlessly. These protocols ensure that data is sent, received, and interpreted correctly, maintaining the integrity and efficiency of the network. At the heart of this intricate network architecture lie subnet masks, playing a crucial role in directing data packets and ensuring smooth communication between devices. Subnet masks are like the unsung heroes of networking, quietly working behind the scenes to keep everything running smoothly. This essay delves into the realm of subnet masks, demystifying their purpose, functionality, and significance in modern networking. By understanding how subnet masks operate, we can appreciate their vital role in managing network traffic and enhancing overall network performance. Imagine a bustling metropolis with countless streets and buildings, each with a unique address. Just as a city relies on a well-organized system of addresses to function efficiently, so too does a computer network depend on a structured system of IP addresses and subnet masks. Similarly, in a computer network, devices need unique identifiers to communicate effectively. These identifiers, known as IP addresses, act as digital addresses for devices on the network, allowing them to send and receive data accurately. These identifiers are known as IP addresses, acting as digital addresses for devices on the network. Each IP address is unique, ensuring that data sent from one device can be accurately delivered to another. However, simply having IP addresses is not enough. To manage network traffic efficiently and ensure that data reaches its intended destination, networks are divided into smaller, more manageable segments called subnets. This segmentation helps in organizing the network and reducing congestion. To manage network traffic efficiently and ensure that data reaches its intended destination, networks are divided into smaller, more manageable segments called subnets. Subnets help in organizing the network, reducing congestion, and improving overall performance. This is where subnet masks come into play. Subnet masks are essential tools that help in defining the boundaries of these subnets, ensuring that data packets are routed correctly within the network. A subnet mask, like a clever postal worker, helps direct data packets to the correct subnet within a network, ensuring that information reaches its intended recipient without getting lost in the digital maze. This analogy highlights the importance of subnet masks in maintaining the efficiency and accuracy of data transmission. Understanding subnet masks is essential for anyone involved in network administration, design, or troubleshooting. By mastering the concepts behind these seemingly cryptic masks, network professionals can optimize network performance, enhance security, and ensure smooth communication between devices. By grasping the concepts behind these seemingly cryptic masks, network professionals can optimize network performance, enhance security, and ensure smooth communication between devices. This knowledge empowers them to build robust, efficient, and secure networks that can handle the demands of our increasingly connected world. At their core, subnet masks are like network traffic directors, guiding data packets to their intended destinations within a network. They play a pivotal role in ensuring that data travels efficiently and securely, avoiding unnecessary congestion and potential bottlenecks. They work in tandem with IP addresses, providing additional information that helps routers and other network devices determine the appropriate subnet for a given IP address. This collaboration between IP addresses and subnet masks is fundamental to the organization and management of modern networks. Just like a postal code helps narrow down a location within a city, a subnet mask helps identify the specific subnet within a larger network. Imagine trying to deliver mail without postal codes. It would be chaotic and inefficient. Similarly, subnet masks bring order to the digital world by segmenting networks into manageable pieces. In essence, a subnet mask is a 32-bit binary number that distinguishes the network portion of an IP address from the host portion. This binary distinction is what allows devices to communicate within the same subnet or reach out to devices in different subnets. This distinction is crucial for routing decisions, as it allows routers to determine whether a destination IP address belongs to the same subnet or a different one. By understanding the network and host portions, routers can make informed decisions on how to forward data packets. By analyzing the subnet mask, routers can efficiently forward data packets to the correct subnet, ensuring that information flows smoothly across the network. This efficiency is vital for maintaining high performance and reliability in network communications. Subnet masks are typically represented in dotted decimal notation, similar to IP addresses. This notation makes it easier for network administrators to read and configure network settings. For example, a common subnet mask is 255.255.255.0. This specific mask is often used in smaller networks to designate that the first 3 octets are the network portion, while the last octet is for host addresses. Each number in this notation represents 8 bits of the 32-bit binary number. These bits are crucial in defining the boundaries between the network and host portions of an IP address. The value 255 represents a series of 8 ones in binary, 1111111, while 0 represents 8 zeros, 00000000. This binary representation is the foundation of how subnet masks operate, providing a clear and precise method for network segmentation and management. To fully grasp the inner workings of subnet masks, one must first understand the fundamental concept of binary numbers. Binary numbers are the backbone of all digital communication and computing. They are the language that computers use to process and store information. Without a solid understanding of binary numbers, it is nearly impossible to comprehend how subnet masks function. It's essential to delve into the realm of binary numbers. Binary, a base 2 numeral system, uses only 2 symbols, 0 and 1. Each digit in a binary number is referred to as a bit. In the context of subnet masks, these bits play a crucial role in determining the network and host portions of an IP address. As mentioned earlier, a subnet mask is a 32-bit binary number, consisting of a sequence of ones and zeros. These 32 bits are divided into 4 octets, each containing 8 bits. The arrangement of ones and zeros within these octets defines the network and host portions of an IP address. The ones in the subnet mask represent the network portion of an IP address. This means that the bits set to 1 indicate which part of the IP address is designated for network identification. The more ones present in the subnet mask, the larger the network portion and the smaller the host portion, while the zeros represent the host portion. The bits set to 0 in the subnet mask indicate which part of the IP address is available for host identification. This allows for the differentiation of individual devices within the same network. When an IP address is combined with its corresponding subnet mask using a bitwise AND operation, the result reveals the network address to which the IP address belongs. This operation is fundamental in networking as it helps in routing and managing IP addresses efficiently. The bitwise AND operation compares each corresponding bit of the IP address and subnet mask. This comparison is done bit by bit, ensuring that the network portion is accurately identified. If both bits are 1, the resulting bit is 1. Otherwise, it is 0. This simple yet powerful operation allows for the precise determination of the network address. For example, consider an IP address of 192.168.1.100 and a subnet mask of 255.255.255.0. This is a common scenario in many home and small business networks. Converting these values to binary, we get the following. The IP address in binary form is 111000000.10100000001.011000010. The subnet mask in binary form is 111111111111111.000000000. Notice how the subnet mask has a continuous sequence of ones followed by a sequence of zeros. Performing a bitwise AND operation on these binary values results in the network address. The operation is performed bit by bit, comparing each corresponding bit of the IP address and subnet mask. The resulting network address in binary form is 1100000000001.000000001.000000000. This binary sequence represents the network portion of the IP address. Converting this binary network address back to dotted decimal notation, we get 192.168.1.0. This notation is more human-readable and is commonly used in network configurations. Understanding this process is crucial for network administrators and IT professionals. It allows them to design and manage networks efficiently, ensuring that IP addresses are allocated correctly and that network traffic is routed properly, which translates to 192.168.1.0 in dotted decimal notation. This example illustrates the importance of subnet masks in network management and the role of binary numbers in computing. The division of an IP address into network and host portions is crucial for understanding how subnet masks facilitate efficient network communication. The network portion identifies the specific subnet to which a device belongs, while the host portion identifies the individual device within that subnet. Think of it like an apartment building, where the building number represents the network portion and the apartment number represents the host portion. All apartments within the same building share the same building number, just like all devices within the same subnet share the same network address. The subnet mask determines the boundary between the network and host portions of an IP address. A subnet mask with more ones will have a larger network portion and a smaller host portion, resulting in more subnets but fewer hosts per subnet. Conversely, a subnet mask with fewer ones will have a smaller network portion and a larger host portion, leading to fewer subnets but more hosts per subnet. The choice of subnet mask depends on the specific requirements of the network, such as the number of subnets needed and the number of hosts within each subnet.